Assalamu alaikum students. After having the knowledge regarding the Faraday's experiments, finally Faraday postulated two laws regarding those very experiments. And those are known as the Faraday's laws of EMI, electromagnetic induction. What was the first law? The first law was Faraday's qualitative law of EMI. According to this law, he simply says whenever there is change in the magnetic flux linked with a circuit or a coil, an induced EMF is set up. What we found from the experiments that whenever there is a relative motion between the coil, once we were having the coil and we were having the magnet, once there was change in the magnetic flux linked with this very coil, then there is production of induced EMF. This was the first law. And this induced EMF lost still there is a relative motion, still there is a change in magnetic flux, not the relative motion, but you have to say the change in magnetic flux. So simply whenever there is a change in magnetic flux linked with a circuit and induced EMF, and hence an induced current is produced in circuit, this induced EMF lost as long as magnetic flux linked with circuit changes. So the flux has to continuously change with the coil, with the circuit, then and only there will be production of what? Magnetic flux. Then and only there will be production of what? Induced EMF, induced current. And the second law, which is called as the quantitative law, that is the qualitative, this is the quantitative law, that how much quantity. According to this very law, it states that magnitude of induced EMF. That is, now the term comes out to be the magnitude. Magnitude means how much. How much by amount. So magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. If more and more magnetic flux change in it, so there will be a lot of magnitude of the induced current. That is simply, we can say, that is from this very law, induced EMF we can represent it by E or small m, directly proportional to d phi by dt, where d phi is change in flux, and this is change in time, change in time. So if we are going to calculate an expression for this very law, so if we will consider, let phi 1, if we will take the example like this, we will calculate the expression, let phi 1 be the flux linked to a coil at some time t1, and after some time t2, if phi 2 is the flux linked with the coil after some time t2, then change in magnetic flux in this very time will be, that is, we phi 2 minus phi 1, that is simply in time of t2 minus t1. So in a time of, as initially time we are having a flux of phi 1, after some time t2 there is a flux of phi 2, then change in flux phi 2 minus phi 1 is equal to t2 minus t1. Then according to the law, induced EMF is directly proportional to d phi by dt, but there is a sign of minus. Why minus? I will make you understand. So you will see, removing the proportionality, it will be, which implies E equals to some constant times d phi by dt, where the value of this very constant is simply 1, or the law becomes as E equals to minus times d phi by dt. Now the minus sign here means that induced EMF always opposes the changing magnetic flux linked with it. So it always opposes the cause by which it is produced. So negative sign means that induced EMF always opposes the changing magnetic flux linked with circuit, due to which induced EMF is produced. Or you will say simply, it opposes the cause by which it is produced. Induced EMF is produced by the change in magnetic flux. So once there is production of now induced EMF, it opposes now the further magnetic flux with which this induced EMF is produced. So that is why there is minus. Now you will using induced EMF like this, then d phi by dt, instead of d phi by dt we will place simply phi 2 minus phi 1 or t2 minus t1. If the coil is having n number of turns, then you can replace this very equation by having E equals to n times d phi by dt, where n is the number of turns. This is the induced EMF. Now, if you are going to check induced current, then induced current I equals to EMF by resistance of coil. EMF, that is simply E divided by resistance of coil, that's R. So that is simply d phi by R into dt. That is the equation for induced current. So simply from this very law we can conclude that how much by magnitude, how much is change in the magnetic flux, that is written in this very law. E, the induced EMF, directly proportional to d phi by dt, where phi 1 is, if you will take the situation, phi 1 the flux at t1, phi 2 the flux at t2, then this is the change in flux. And just the negative sign here implies that it opposes the cause. This induced EMF which is produced in the coil, it opposes the cause by which it is produced, that it is produced by change in magnetic flux. Now it opposes it, because once there is induced EMF, then it itself becomes as a magnet. It opposes now it further motion, further relative motion of this very magnet. So this is the equation for induced EMF, and this is the equation for induced current. This is all for today. Tomorrow we will be with another lecture. Till then, Allah Hafiz.